Alright, good morning. So right now I'm going to go over the Chapter 4 practice test multiple choice section and the short answer section of radicals. So your practice test looks like this. That's what I'm going to be going through each of the questions, but I'm going to write them bigger and write them on this blank paper instead. So your first question is the sixth root of 4 to the power 8. What is the radicand, it asks. So the answer to this question is just 4 to the power 8. It's just whatever is underneath the radical symbol. What's this called again? This one's called the index, but it didn't ask anything about that. Okay. Question 2, you can see I kind of messed up here, but I have it over here. We have the fourth root of 256 over 625. So we can type this in our calculator if we wanted to, or if you were able. In my calculator, it's done this way. This is the easy way to do it. I'm going to show you the other way you could do it. So I'm going to hit 4 because that's the index. And then I'm going to go to my math button here. And then I go to this one with the X there. And I hit enter. So it's the fourth root. It means the 4 replaces the X of, and then I'll put brackets 256 divided by 625. Close the bracket. So it says my answer is 0.8. Okay, and that's the same as 4/5. So that's a calculator way to do it, but I wouldn't recommend doing it this way, especially if you get bogged down with all the calculator buttons. So how we would do it is the prime factorization is 256. We have to break that down, and we also have to break down 625. Okay, so 256, we know 2 goes in there, and then that leaves us with 128. We can take out a 2 again. That leaves us with a 64, and then a 2 again. We can keep taking 2's out. There you go. How many 2's do we have? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 2's. Okay? So let's rewrite this top one. Let's see, do we have 8? Not yet. One more. And then the 625 is not as bad. We can break it down. There you go. So now this is 4 5. So the bottom's going to be 5 times 5 times 5 times 5. And now we have the fourth root of 8 2's and 4 5's. So if we group them up, we need to take groups of 4. That's what the index tells us. So we can do those 2 groups, and we can also do the bottom here. So we're going to have a 2 and a 2. So all those 8 2's is just represented by 2 2's on the outside, because we took this group, that's that one, and took that group, and that's what that one is. You still need a division symbol if you're going to take out these 5's. You have 4 5, so you can take out one group of that. And your leftover, you took out everything, so you just put a 1 because they've all been used. So now we have 2 times 2, 4. That 5 is still there. And then it's the fourth root of 1. What times itself 4 times equals 1? And that's just 1. Okay, so times 1, which is just 4 over 5. So that one was a big question. All right, now this next one here, which of the roots lie between 3 and 4? So I see all these numbers. They're all confusing, but if we look, we have a negative symbol and a negative symbol. We know though those are cube root, so our answer is going to be negative, and we know that doesn't lie between 3 and 4, so it's not going to be those two. So now we just have root 17 and cube root of 28. The difference here is one has an index of 3, one has an index of 2. When it doesn't have anything, it's a 2. Okay, so cube root of 28, we have to find out if that's between 3 and 4. Okay, so one way is you can just type it in your calculator, or we can look at this. Let's look at what the cube root of 3 is. We have 3 to 4 is where we have to get to. So 3 times, or 3 cubed is equal to, 3 times 3 is 9, times 3 is 27, and 4 cubed is 64. So we know if we have a cube root of 27 and a cube root of 64. It has to lie between the 27 and the 64 for cube roots. Okay, is 28 between 27 and 64? Yes. So therefore this has to be between the 3 and 4. So that is, let's just check quickly. I can go, in my calculator, I can go math, and then I go down to this one that has a cube root, and then I can write 28, and I get 3.03. So that's between 3 and 4. So that one is. This one, square root of 17. Okay, so this one, we can just type in as well. Square root of 17, 4.12. So we know that's above, so that won't be. So our only answer is cube root of 28. All right, question 4. We have all these. It says, which of the numbers is irrational? So this is another calculator one. I'm going to go square root of our first one, which is 48. Seems to go forever, so that one would be irrational. Now let's try cube root of 216. Okay, if we don't know how to do it in our calculator, we can prime factorization, the one in the radical. All right, so math, cube root 216, and we get a 6. So that's just a 6. This one is irrational. This one's not, because it's just a 6. Okay, this one here, let's go square root of 49 over 16. And we get 1.75. That one terminates, so it's not irrational. And the negative 68 terminates, so it's not rational either. So it's just not irrational, sorry. This one's root 48, so that one has to be irrational. All right, question 5. We have all these numbers here. We have 5 numbers, and it says, write them from least to greatest. So how do you know if this is bigger or less than that? You can't really tell just by looking at it. The only way to do it is to put it all under the same indexed radical, so that they all look the same, and then you can compare them. See, you can compare root 14 and root 17 easy just by looking, because 14 is less than 17. You know this one's less than that one, but not so easy with mixed radicals, so let's convert them all. The 3 root 2 is going to be the same as 3 times 3 times 2. We bring that 3 on the inside, and because the index is 2, you change 1 3 to 2 3s. So now we have root 18 is that one. This one's just root 14. This one we can convert, 2 times 2 times 6. So that's root 24. This one here is just root 17. And then this one's a mixed radical, so let's change it to an entire radical by going 2 times 2 times 3. Again, changing the 2 into 2 2's because the index is 2. So that can be root 12. Okay? So we know that this one's the least, so that one's the least. And then our next one is root 14. And then our next one is root 17. Then our next one is root 18 here, which is this. And then our last one, our greatest one, is 24, root 24, which is that. Okay? All right, number 6. Which of these numbers is an integer but not a whole number? So if we look at this, this one, is that an integer? Yes. Is it a whole number? No. So that one is an integer but not a whole number. Is this one an integer? Yes. Is it a whole number? Yes. So it can't be that because it is both. And this one is as well. It's an integer and both a whole number. Again, a whole number just means it's an integer that's 0 or greater, no negatives. So this one here, root 5, is not an integer, right? Because if we type that in our calculator, we get this kind of irrational number, okay? And irrationals just are kind of on their own. So that's not the case. So it's just negative 9. Number 7. To which sets of numbers does negative root 25 belong to? So let's convert that or simplify it to negative 5. Because root 25 is just 5 times 5, or 5. So negative root 25 is the same as negative 5. So what does this belong to? We know it's an integer. We know it's a rational. And we know it's a real number. Okay, it's not a whole number, not a natural number, not an irrational number. Okay, so that means it has to be 2 and 3. Okay. Now this one here, number 8, 3 and the 4th root of 2 as an entire radical. It's not an entire, it's a mixed right now because the number 3 is on the outside of the radical. So let's bring it to the inside. So how we do that is we rewrite with the same index. You never change the index. So we can write that 2 again. We just have to write this 3 as 4 3s. So you change 1 3 to 4 3s because that's what the index tells us. Okay, now that's a big number. I won't be able to do that in my head. So I'm going to go 2 times 3 times 3 times 3 times 3, and we get 162. So we keep the same radical with the same index, and that's what our answer will be for that one. Okay, number 9. We have cube root of 1372. Okay, and it says write it in simplest form, or that just means change it to a mixed form. Okay, so we need a number in the front. So 1372, that one's a big number, so I'm going to prime factorization it, so I'm able to take something out. Okay, I see a 2 there, so I know a 2 can divide into there. So 2, so let's go 1372 divided by 2. And I get 686. I know I can take a 2 out again, and that'll give me a 343. So this time, the 343, I'm not exactly sure what goes in there. I know the last digit is odd, so I'm going to try odd numbers. 343 divided by 3 doesn't work because it's not a whole number. So now I can go 343 divided by, I know 5 won't go in there, so I'll try 7. Okay, that works. So we know a 7 and a 7. All right, so now I have prime factorization this number. We have a 2 times 2 times 7 times 7. Okay. And did I do anything wrong? Yes, I did. This is supposed to be 49. 7 times 7 does not equal 343. And that's supposed to be like that. So I missed just one extra 7 there. Okay, so now overall this 1372 we know is a 2 times 2 times 7 times 7 times 7. Okay, now let's take anything out we can. We can't take out the 2's because there's not 3 of them. But there's 3 7's, so we can group those together and take 1 out. So it's cube root of 4. Okay. All right, so number 10. It says cube has a volume of 1200 cubic inches. So here it's saying write the edge length of the cube as a power. Okay, so that has a lot of words to it, but it's actually not too bad of a question. This cube goes with the unit, not with the number. Okay, so our answer or our volume is just 1200. Okay, if we want to find a side length, we know a cube is length times length times length, or length cubed. Okay, and our volume is 1200. It's saying. Okay, if you want to solve for L, you have to get rid of this cubed. So you have to bring it over. Okay, the opposite of cubed is cube root. So we can write L is equal to cube root of 1200. So here, L is equal to cube root of 1200. So it just wants us to write that as a power. Okay, right now it's a radical, not a power, but we can convert any radical into a power. 1200, and what does the index go? It goes on the bottom of a fraction in the exponent. So it's going to be something over 3. Okay, what's the something on top? Well, there's no exponent here, so we can just write 1. Okay, so the cube root of 1200 is the same as 1200 to the power of a third. Okay, that's our answer there. Now this next one is 11. Evaluate 2 over 3 to the negative 3. Okay, so when I see this, you can distribute this into each number, or we notice that this is a negative, so we can swap the whole fraction because the big brackets are surrounding everything. So we can go 3 over 2 to the positive 3. We're allowed to do that. We're allowed to swap it and change it positive. Okay, so now we can distribute in. Again, it doesn't matter what order you do it as long as you're doing the correct procedure. So 3 to the power 3 over 2 to the power 3. 3 times 3 is 9, times 3 is 27. 2 times 2 is 4, times 2 is 8. 27 over 8, we've evaluated this, or we've simplified it. Okay. This next one, 12, we have this very complicated thing it looks like. But one thing I notice is the bases are all the same. Okay, so that allows me to do exponent laws, which is very nice. Those two bases are being times, so that means we can add the exponents. Okay, so the top is 3.5 to the power negative 1, because negative 6 plus 5 is negative 1. But I still have to write that bottom one, so I'm going to do that. There you go. And now we still have the same bases, but this time it's being divided. So that means I can subtract the two. Negative 1 minus negative 1, they just cancel out because they're the same thing, right? Negative 1 minus negative 1 is 0. So now we get a 3.5 to the power 0. Okay, and that's our answer. That's what it shows in the book. One thing to remember, that's just equal to 1 overall. But our answer for the multiple choice is 3.5 to the power 0, because these two end up canceling out. All right, number 13, we have 64, A12, B15 to the power 2/3. So the first step I'm going to do is I'm going to distribute this 2/3 to each one. Okay, so 64 to the 2/3, and we have A. We have to know what to do here. When you're distributing a 2/3 to an exponent, exponent to an exponent is multiplication. So 12 times 2/3, 12, it's kind of the same as 12 over 1 times 2 over 3. 12 times 2 is 24. 1 times 3 is 3. So when you're multiplying, not adding, that's kind of the procedure you do. Okay. So this is going to be 24 over 3. Now we have to do the same thing for 15. So 15 over 1 times 2 over 3. 15 times 2 is 30. 1 times 3 is 3. Okay. So our B is 30 over 3. So now this can be simplified to this. Let's see if we can simplify it any further. Here, this is the same as the cube root squared. 24 over 3 we know can simplify to 8. And we know 30 over 3 can be simplified to 10. So now we're at that step. I can just simplify this now. Okay, so the cube root of 64, not thinking about the squared right now, the cube root of 64 is 4 times 4 times 4. So we know 4 is the cube root of 64, but that square will still be there. Okay, a to the 8, b to the 10. So now it's 16, a to the 8, b to the 10. That's our answer. All right, last page. So now we have 14 multiple choice. We notice this very complicated thing, but it's actually not bad. If we look, this whole bracket is the same as that whole bracket. So they're the same base, which means we can do exponent laws. We can just, since they're being multiplied, we can add the tops. 7 over 4 plus 1 over 4. Okay, this is a bit different than the last one, because the last one we multiplied. What do we do with plus? You keep the bottom the same, and they have to be the same to add. So they are the same, that's good. So we can just write 4 again, and you add the tops. So this is supposed to be a 7. 7 plus 1 is 8. 8 over 4. Okay, we know 8 over 4 can be simplified to just 2. Okay, so now I can rewrite the same base, negative 8 over 5. And we can just write it as 2. Okay, and I just got to find this one. Now we have to distribute this squared to the inside. Okay, but it also has to distribute to that negative sign. Negative times a negative is a positive. So we get 64 over 25. All right. Number 15. We have m cubed n to the negative 3 to the power negative 1 over all of this. Okay, so there's lots of steps or lots of ways you could do this. The first step I would do is distribute this negative 1 to both of them and this 4 to both of those. Okay, so here we have m to the negative 3, because 3 times negative 1 is negative 3. And then we have n to the positive 3. And then here we have 4 times negative 2 is m to the negative 8, n times, which is 1 times 4 is n to the power 4. Okay? So we have this so far. We're not done because we have negative exponents, and we don't like negative exponents, so we want to switch them. This negative one goes to the top, this negative one goes to the bottom. So let's just rearrange that. M to the 8, the n's stay where they were, m to the 3, n to the 4th. Okay, these two bases are the same, so we can do exponent law. 8 minus 3 is 5. Where does the m go? It goes with the bigger number. 8's the bigger number, so we'll put the m on the top. Okay, here we'll go 4 minus 3, and since the 4 is the bigger number and it's on the bottom, we're going to put a result on the bottom. 4 minus 3 is 1, so it's going to be n to the power 1. So that's our answer there. Okay. Now we're on to short answers. So if you look on your practice test, it looks like this. We just have the 3 questions there, and that's the end of this video. So the 4th root of 810, it's saying simplify, okay, or write as a mixed fraction. So how we do this is we have to prime factor it. So we know 5 is going to go in there. So I'm going to go 810 divided by 5, and we get 162. I know 2 goes into there. So let's divide that by 2, and we have 81, and we know 9 times 9 is 81, and then we know each of those is 3 times 3. Alright, so it's 3 times 3 times 3 times 3 times 2 times 5. Just the branches of the tree. So let's rewrite this 4th root as 5 times 2 times 3 times 3 times 3 times 3. Alright, so it's a 4th index, so I have to group things into groups of 4. We know that the 3's are the only thing we can group there. So I can take 4 3's out, but it only converts to only 1 3 when you take it out. And then it's a 5 times 2 there, so it's 3, and the 4th root of 10. Okay, one thing to note here is this 4 is not correspond with the 3, but corresponds with the index of the radical. Alright, question 17. It says, write 8 root 19 as an entire radical. So let's bring the 8 in. So now we have 8 times 8. Since there's nothing shown here, it means it converts to a 2 times 19. And then I just type this in my calculator, 8 times 19. So now we have 1216. All done. Alright, last question. It's saying simplify this complicated thing. I see lots of negative exponents, so I'm just going to swap them. I'm going to bring this to the bottom, this to the top, this to the bottom, this to the top, this to the bottom, this to the top. Okay? So let's do that first. A to the 6, B to the 3, and I change them all to positive exponents. A to the 3, B to the 7, C to the 6. Alright, so now we have all of this. These are like bases, so I can subtract 6 minus 3, and I can keep it where the bigger number was. So it's negative 3, A to the 3. 7 minus 3 is 4, but it goes to the bottom this time. 6 minus 3, but it goes to the bottom, is 3. Alright, we're there, and then we have negative 3, A to the cubed. Sorry, I got to get rid of negative 3, and a 12 can be simplified. So 3 goes into 12 4 times, so we know that this is the same as 4b fourth c cubed with a negative sign still there. Okay, a negative sign being on the top of the fraction is the same as it being in the front. It doesn't matter as long as there's just one negative sign. So overall I simplified the 3 over the 12, and I got the 4 on the bottom because the bigger number's on the bottom. So that's our answer there.